Okay, so 7.6, indirect proofs. So these are similar, but actually quite different than a conditional proof. The similarity is that you set them up very similar. In other words, you have to indent. The difference is, with the conditional proof, you're always starting with the antecedent, then you're ending up with a conditional statement. Here, you are going to take the conclusion, whatever it might be, and you're going to put a negation in front of it. Now, what you're going to be doing is making an assumption for an indirect proof, and that will always be your assumption as a negation of the conclusion. For right now, by the way, later on you may have to make a negation of some type of premise, but that'll be later. So, what you're going to do is put the negation on it, and then what you need to find is a contradiction. So what this shows is, assuming that this statement is true, you end up with Y and not Y being true, which, if you remember from our long truth table days, that cannot be. Okay? It just makes no sense. It should make your brain hurt just a little bit. Okay? So whenever you find a contradiction, whatever is up here, it's not true. So that means you've just shown that this has to be false, so this one over here has to be true. And that is the whole idea behind an indirect proof, is finding that contradiction. And once you have that contradiction, then you can put a negation on whatever you started off with. In this case, we already had one, so we're just going to put another one. And then we're going to use that double negative rule. And then we get the conclusion. And then everything inside of here is still just the same. Okay? So that's the main idea of how to set one up. Oh, and by the way, it doesn't matter what the contradiction is, just find a contradiction. And a lot of these problems, there's multiple contradictions that you can find. Okay, let's look at another one here. Okay, so this one's going to be bigger, but still exactly the same. Okay, you're going to start off by looking at the conclusion, and since it has parentheses already, you're going to put brackets around it, and you're going to put a tilde on the outside. Now, for the most part, something like this is just a lot of breaking it down. Okay, so the first step is De Morgan. So you're going to put the negation on this one, then the negation on this one, and then change the sign. And then once you've done that, you have that dot, so you can break it off and simplify it. And then, when you have something like this, okay, so you have a negation, but you can't do De Morgan on a horseshoe. So the key is do implication inside, and then you can do De Morgan. Okay, so if you have B to Z, you're going to end up with not B or Z on the inside. So just do implication, and then as you can see, now this looks familiar. Okay, so all I did was do De Morgan here, and then I just did a double negative to get rid of it. And so once you get something like this, then you can just simplify. And as you can see, look at all the simplifies here. This is all you're really doing. You're taking something that is this big up here. Just a second. Okay, you're taking something like this, and you're breaking it down into its smallest components. As you can see, you get B, you get not Z, you get Y, you get O. And then, once you get everything broken down, then you come back up here and you start looking at the premises. Okay? And I know this may seem like a jumble of garbage right now, but this is honestly how you work out indirect proofs. It's all about getting it down to its simple component. Okay? I would take time and go over that example. And just to let you know, you can do conditional proofs and indirect proofs in the same one. Okay, so this one you started with not M, that's your antecedent. Then your next antecedent was K. So now your goal is Z. But if you look at it, you got M, you got K, and you just look at 1 and 2, well, there's not much we can do with that. So take your Z, put a negation on it, and see if you can do something with that. This is really just trial and error. I'm trying to give you as many examples as I can, but at the end of the day, it's about you trying to figure things out. And the answers I give you, they may not be exactly the way you did it. Just as long as every single line is a valid interpretation, you should be fine. And if you're wondering if it's okay, go back to the cheat sheet, and if you want to, take a picture of it and email it to me, and I'm happy to go over it with you.